For those of you at home, today we're going to run through the power rules, rules of exponents and laws of exponents. And so one of the sheets that you were given already has all the basic rules on it, the multiplication rule where you add the powers, the division rule, power of a power rule, then we have power on a product rule. You can read them all. Fractions, how it breaks down, zero exponent, etc., fractional exponents. So that's what we're going to work through today. So we'll just jump right in and start doing some problems. One thing that I can tell you as a word of advice is there's not really one right exact way to do this, so different people might do things in different orders, and I'll just sort of talk through what I'm thinking. So in this first problem, I am going to start by combining the stuff on the top, the m squared that I have here, with the m to the first that I have next to it. So my new top looks like n m cubed p. And then on the bottom, I'm going to bring that power through. And one of the rules says if you have a power on it, it goes through to everything. And the other rule is it gets multiplied by the powers. So this 2 has an invisible first power on it. So 1 times 2, that's going to be 2 squared, m to the fourth, n to the negative second, p to the negative eighth. Okay, so now my next move that I would personally do is I would move negative powers to a new position. If they're negative on top, they go down to the bottom. If they're negative on the bottom, they move up to the top. And again, there's not one exact right way to do this, but this is where I would go next. So I would do n times n to the second. That's that negative second power down there that moved up to the top. And then it's times m cubed times p to the first times p to the eighth. I suppose I could put a first up on that n as well. So these two things here that I'm underlining, the n to the negative second, p to the negative eighth, moved up to the top. And then on the bottom, I could write it as 4. 2 squared is 4, m to the fourth. So I have n cubed, m to the third, p to the ninth, over 4m to the fourth. Now the last move that I'm going to make is that I have m's on both the top and on the bottom, and even though the rule is to subtract, I would do 3 minus 4 technically. What I do is I look at how many do I have on the top and on the bottom, and where are there more. So I have 3 m's on the top, I have 4 m's on the bottom, so there's one more on the bottom. That means when I do my canceling, all of them will cancel off the top, and I'll be left with 1 on the bottom. And so there's my final simplified form. So again, there's not always one right way to do this. You might find some problems you start in one way and other problems you start another way. It's kind of a personal thing what you see in this next one. I think I'm going to start by cleaning up the inside. That will be my beginning, and then I'll worry about the power on the outside later, because if I do that now, I'm going to have a lot of stuff that I'm working with. So if I clean up the inside, start on the top, the 2 times the 2 is the 4, the q to the negative fourth, r, I've got r to the first and an r to the third, so that's r to the fourth, r to the fourth, that's a 4 there, p to the negative third, and then over 2p to the fourth, and then all of that is raised to the fourth power. I'm still going to continue to do some cleanup. So I notice that I can reduce the 4 and the 2. I have those two things. So when I reduce that down, I'm just left with 2 on the top. I'm sort of just dividing it like a fraction. And then I'm going to leave the r on top, but the q that was this q right here, negative fourth, I'm going to bring that down to the bottom and make it positive. And the p right here, that's a negative power, I'm going to bring that down to the bottom and make it positive. And so then on the bottom, it looks like I can combine my p and my q. I have to remember that this is still all raised to the fourth power because I didn't do that part yet. So I have 2r to the 4th over p to the 7th q to the 4th, and all of this is going to be raised to the 4th power. So my last move will be to do that to the 4th power. So I have 2 to the 4th r to the 16th over p to the 28th q to the 16th. Maybe I'd take one last move. You could leave it like this, stop here, but maybe I'll do this part here, the 2 to the 4th. That's 16 r to the 16th over p to the 28th q to the 16th. And so then there's my final answer on that one. Again, how you simplify kind of becomes sort of personal, and our end result is what we're looking for. Sometimes I start one way and I just don't seem like I'm going anywhere fast, and so I'll stop and start a different way, and that can happen. So just sort of work through it and see what you come up with. So here's another problem where I'm going to combine on the inside first. The j squareds, I've got one on the top and on the bottom, so those are going to disappear. I'm going to do some cleanup on the bottom. The negative 4th power will stay on the outside. And so I've got a 2k and a 2k right there. So that's going to be 4k squared when I combine those things. Then I have this h squared and h to the negative 4th. That would give me h to the negative 2nd because I'm adding those powers together. Okay, so now I have got to deal with this negative 4th power, and so I'll just bring that right through. Remember, if I don't see a number on it, I can assume the power is 1. So I have 1 to the negative 4th power, 4 to the negative 4th power on the bottom, k to the negative 8th, and h to the positive 8th, because a negative times a negative is a positive. So then I'll do my move around. Positive powers will remain where they are. Negative powers will move to from the bottom to the top or from the top to the bottom, depending on the situation. So I have 4 to the 4th, k to the 8th. Those negative powers moved up from the bottom. And then over 1 to the 4th, h to the 8th. So then the last thing I need to do here is figure out what that 4 to the 4th power is. And so however you need to do it, if you have a calculator handy, you can calculate it that way, or if you just happen to know what it is, I'm going to end up here with 256 k to the 8th all over. Well, this 1 to the 4th is 1 times 1 times 1 times 1, so it's just 1. I don't even need to write it, h to the 8th. And so there is my final on that one. So the last few, or the last couple that we did, had a big power on the outside, and I cleaned up the inside and then went on. Well, on the next one, my only power that I have on the outside of a parenthesis is only attached to the bottom. And so there are, again, in this problem, maybe I'll look at things a little bit differently, but I'll just follow the rules as they go. I'm going to start by, again, maybe cleaning up the top a little. So I see the 2 and the 2. I'm going to multiply those together, 4. Then I also notice that I have an x here to the negative 1st and an x to the 3rd. So I'll add together those powers, x to the 2nd. I have a y to the 2nd, y to the negative 2nd. Well, that will become, they sort of cancel each other out because it'd be y to the 0 power, which is 1. And then 4 plus negative 3 gives me z to the 1st. At the bottom, I can't do any cleanup inside, so I'll just bring that negative power through. So z to the negative 3rd, x to the 6th. And then I can go ahead and do any last minute cleanup that I can do. The only thing I see, well, I see two things. I can work with the x's. The 4 is going to remain. And the x's, I've got 2 on top and 6 on the bottom, so I have 4 more x's on the bottom, and the 2 on the top are going to cancel out. And then this z to the negative 3rd is going to move up to the top, and I'll have z to the 1st and z to the 3rd. So then when I do my final simplifying, I'll have 4z to the 4th over x to the 4th. And there is my final setup. So of course we're going to start bringing some fractions into our problems too as well, and that's what happens next. Now the rules don't change. Keep that in mind. The rules are going to be the same. You're going to add the powers if they have like bases and multiply powers on powers. So if you're terrible with fractions, I would say take a few moments and find yourself a fraction calculator that you can work through, because I'm not going to go through all the steps on the fractions. I'm just going to do the rules. I'll maybe write some down a little bit more so you have a reference, but as far as how I'm getting the final answer, that's kind of up to you. So on the top, I'm going to combine the x's and combine the y's. So I have x to the 1/4 plus 2, and then y to the 1/3 plus 1. And then on the bottom, I can bring that power through, x to the 4th, y to the 1st, because that would be, I should do this, 1/4 times 4. So plus when the bases are the same, but multiply when you have a power on a power. So now let's do all the fraction work with that. X to the 2 1/4, but I always like to write it as a improper fraction, so that's 9/4. Y to the 1 1/3, or 4/3, over x y to the 1st, 1/4 times, sorry, x to the 4th, y to the 1st. And so now I'm going to go ahead and do my subtracting of my values here. So I have more x's on the bottom. There are 4 x's on the bottom and 2 1/4 on the top. So when I do that, I'll end up with x to the 4 minus 9/4 power. And on the top, I have more y's, so that'll be y to the 4/3 minus 1. So now when I do the math on that, I have y to the 1/3 over x to the, let's see, 7/4. So that would be 4 minus 9/4. Again, I'm just plugging in your calculator, or if you know how to do the math, do the math. I did a common denominator. 16/4 minus 9/4 gave me 7/4. All right, so now here's another problem that we have to take care of. One of the rules is you can't have rational or fractions in the denominator for powers. So they call those rational powers, and so I have to get rid of that, and I do that by making the denominator a whole number. So x is the issue, so I'm going to have to multiply the top and the bottom. This is called rationalizing, by something that's going to make that a whole number. Well, I have 7/4. The next whole number would be 8/4, because 8 divided by 4 is 2. So I'm going to multiply the top and bottom by x to the 1/4 power. And so when I do that, I'll have y to the 1/3, x to the 1/4, over x to the 8/4, or better than that, y to the 1/3, x to the 1/4, over x to the 2nd. Now, people say that doesn't look simplified, but it's what we call rationalized. We rationalized the denominator, getting rid of any rational exponent in the denominator. And so I know that I have an x on the top and on the bottom. I want to make sure that I leave those there. All right. I am finished now with that problem. Let's move on to the back page and work through. It's just kind of going to be a repeat of the rules. And so if you want to at any point pause and work your way through and check your answers when you're done, that's great. Otherwise, we can just continue to work through here. In this next one, I am going to leave the squared on the outside. I'm not going to touch the top right now here. But on the bottom, I recognize that I have an x squared and an x to the 5/3. So I'm going to combine those together. I'll get x to the 11/3, and then a y to the 1st. And so I can here clean this up when I do my subtraction of the powers on the x's. I am a higher power in the bottom, so I will subtract those. That is 11 thirds minus 5 thirds. Oh, I recognized something that I didn't see before. I guess I could have canceled that out right away. That would have made my life a lot easier because I'm going to end up with x to the 6 thirds. See what I mean? How sometimes you miss something and there's not exactly one right way to do this. On the top, I have y to the 1/4. When I subtract that, 5/4 minus 1. Then I can bring my power through. So that's y to the 1/2 over x to the 6 thirds is equivalent to 2, so x to the 4th when I'm done with that. And that becomes my final answer on that one. I don't have to worry about the fraction being in the top, that they don't care about a rational power in the top. They care about it in the denominator, and the denominator has a whole power on it. So I'm just going to rerun through that one because, like I said, I could have done right away off the bat. I'm going to go ahead and erase it and do it a quicker way because that's something that can save you some time. If I had been paying a lot of attention or right away saw that, looked closer, took the time to look a little closer, I would end up with y to the 5/4 over x squared y all squared. And then I just have my y's to work with, y to the 1/4, because remember that's 5/4 minus 1 over x squared. I'll take that and square it, and I'll bring that power through. So that's y 1/4 times 2 is 1/2 over x to the 2 times 2 is 4. So same problem, but that one went a little quicker because I caught that part right away, or that piece right away that I could cancel out. All right, moving right along. We're going to just continue and keep cruising through here. So this problem doesn't look too bad. I've got a power on a power. I'll multiply that. 5/3 times 1/2. That's x to the 5/6. Multiply the top, multiply the bottom. Y 1/2 times 2 is 1. 1/2 times 2 over y to the 3/2. So I have more y's on the bottom. It's 1 on top and 1.5 on the bottom. So my x I'll leave up at the top. 5x to the 5, x to the 5/6. Try that again. Ignore that stuff. Over y to the 1/2. This is again a time where I need to rationalize my denominator, so I need that to be whole. So my next whole number would be 2/2. So I have to multiply the top and the bottom by y to the 1/2. That leaves me with x to the 5/6 y to the 1/2 over y to the 2/2, or just y to the 1st, or just y. Just a couple more to run through. Again, if at any point you need to back up and try again or rewind, go for it. I'm going to start on this one by doing some cleanup on the inside that I recognize again. Like, for example, the a's can cancel out. I have an a on the top and an a on the bottom. And also on the top, I can combine my 5/3 and 7/4. So I'll do 5/3 plus 7/4. And I like to keep it improper. So I'm going to have a to the 2nd, b to the 41/12 over b to the 1/2, and then I will raise that to the 5/4 power. So I'm going to work with my b's now on the inside. I'm not going to touch that a to the 2nd. I have more b's on the top, so I do 41/12 minus 1/2. And I get, oops, converted into a mixed number, or an improper fraction. I mean, I get b to the 35/12. And I've cleared up everything, because remember what I did was b to the 41/12 minus 1/2. So that cleared off the bottom, and that's how I got the 35/12. I have to take all that to the 5/4 power. So I'll multiply that through. So that's a to the 5/2, a to the 5/2, b to the 35 times 5, 175 over 48. And that's a pretty ugly answer, but they're not always that pretty, so I'm not going to worry too much about it. So a to the 5 halves, b to the 175 over 48ths. That was the 5 times the 35 on the top and the 4 times the 12 on the bottom. All right, we're down to our very last problem. One more that we're going to do together. It brings in that 0 power. That was one of our properties that we touched on a little bit, but that anytime you see anything to the 0 power, you can replace that with a 1. So this one looks kind of complicated. So I'm just going to kind of work my way through it slowly. I've got these powers on these brackets on both the top and on the bottom, so I'll start by bringing that through. I get x to the 1/2 when I do negative 3/4 times negative 2/3, and then z to the negative 10/9 over, I'll bring that power of 2 through, x squared, z squared, y to the 4th times z, x to the 3/2, y to the negative 1/4. Okay, so that's still pretty ugly. I did a little bit, but not a whole lot of cleanup. Now I'm going to try and combine what I can. I'm going to work on the bottom here. This bottom is pretty icky to me right now. So I'm going to leave the top alone for now. X to the 1/2, z to the negative 10/9. We'll revisit that in a little bit. But on the bottom, I can combine the x's. So x squared and x to the 3/2. So that would be x to the 4/2 plus x to the 3/2 is x to the 7/2. Just found a common denominator. I'll work with the y's as well. So I'm going to do 4 minus 1/4 technically, or plus negative 1/4. So that's 3 3/4. So I just need to convert that into an improper fraction. And that looks like 15/4. So 15/4 will be on the bottom. 15/4. That's a 15/4 on the bottom. And then I'll work with my z's. That was an easy one, z cubed. Okay, so I had the z squared right here and the z to the 1st. All right, so now I want to do a little bit more. I have more x's on the bottom. So I'm going to do x to the 7/2 minus 1/2. So that leaves me with 6/2. I'll change that to 3 shortly. And then my y is just going to stay at the bottom. That was pretty ugly, but it was 15/4. And then my z, I'm going to bring that z to the 3rd stays there, and z to the 10/9 will come down and become positive. Well, now I wiped off everything off the top, so I replaced that with a 1. And then I can combine my z's. So 1 over x to the 3rd, 6/2 I reduced down to 3rd, y to the 15/4. And then z, I'm going to have to add those together. So I'm going to do 3 plus 10/9. And put that in proper. So z to the 37/9 is what I end up with there. I'm in a position again where I have fractions in the denominator that I need to get rid of. The x cubed I don't care about. That can stay down there. It's a whole number. So I know x cubed is going to end up in my final answer. But the 15/4 and the 37/9 are what bug me. So I'm going to have to multiply y and z on the top and on the bottom to some power that's going to make that whole. So 15/4 is 1/4 shy of being a whole number. 16/4 would be 4. So I need 1/4 more. Now how about 37/9? So that's a little bit more difficult. 36/9. 36, 9 goes into 36 4 times. So I need quite a few more ninths. It looks like I need 8/9 to get this up to 45 ninths. So I'll multiply the top and the bottom by 8 ninths. And so again, what I'm trying to do is make it so I can divide by, or divide it into a whole number. 9 doesn't go into 37 evenly. It's got a remainder of 1. I want a remainder of 0. So I need 8 ninths more to make a remainder of 0. So when I do that on the top, I forgot to put my 1/4 up there, I'll have y to the 1/4 and z to the 8 ninths. But on the bottom, that's going to make it 16/4, or y to the 4th, 16 divided by 4, and z to the 5th, because that would be 45 ninths. And so there's my final answer on that one. All right, so again, if at any time anything bothered you, please go back and check it out, take a look at it. But your job is going to be to work through section 1, 2, either the evens or the odds, whatever works for you, and then come to class with questions the next time we meet. All right, I hope you have a great day.